Good morning. In this class, we're discussing about a case study of one-dimensional problem. So I give some example for you. Okay. So for example, if I have consider two different types of composite material, I have to assemble and I have to fix in the two end of the gun. Okay. After that, I have to find out what is the displacement of this case. Okay, and also I have to load and apply on the particular directions based upon our given problem. Okay, so what are the data available and substitute the formulas. Okay, so what is my final outcome of this displacement? Okay, now the algorithm is explain the how the sum is proceed to find out the unknown displacement for the each nodes.
A bar of the figure, a bar of the showing a figure, the action load of 200 kN in a radar at the point of P taken as a A1 equal to 2400 mm square, E1 equal to 70 into 10 to the 9 Newton per meter square, P2 equal to 600 mm square, E2 equal to 200 into 10 to the 9 Newton per m square. Calculate the following of nodal displacement of the point of P, stress in each element, the material, the reaction force. Given it a equal to 2400 mm square, A2 equal to 600 mm square, E1 equal to 70 to 10 to 9 into Newton per mm square, E2 equal to 200 into 10 to 9 Newton per m square.
Yes. So the algorithm read the question is correct. So he read the question, what are the data is given. So the particular element area is given, particular element the length is given, and also the load is also given. Okay. So what is the next step I have to do? So you have to find out the stiffness matrix. That is the foremost thing to calculate this. Okay. So my FEF problem to solve, F is equal to K into U. That is a force K and U. K is called the stiffness matrix. So based upon the load, okay, based upon the conditions given your problem, you find out the stiffness matrix of K1 and the stiffness matrix of K2, okay. And we have to substitute assemble this matrix, and substituting the general matrix, you got the unknown displacement. This is the outcome of to solve this problem. That is a step-by-step process of to solving this problem, okay. And how the data is substituted, how the node can be assumed. For example, the element, if I consider as element 1, okay, what is the node number given? 1 and 2, yes, and the 1 and 2 also is substitute. Okay, so 1 and 2, okay, and then the right as the horizontal and the vertical. Similarly, the element 2, I have to substitute as a 2 and 3. Yes, correct. So if I am substituting data, okay, 1 and 2 and 1 and 2 and 3, okay, and assemble them. First, you have to consider the square matrix. That is the square matrix is called as the stiffness matrix. That stiffness matrix is size of what? 3 and 3 into 3. That is called as a element stiffness matrix. Is correct. So now you can substitute data according to your numbers is that. Okay. For example, this is 1, 1 means what is the data? 2, 2 is what is the data? What is the data you have to return? You have to copy paste and write it. Okay. Then what is the next one? 1 to 3. There is 1 to 3's answer is 0. Why? Because there is no numbers is there. So that's why I put as a 0. Then similar, you have to find out the 1, 2 and 2, 2. While coming the 2, 2 is a common for the element 1 and element 2. Yes, correct. So that we add the numbers of the previous of stiffness matrix 1 and the previous second. That is now to find out the stiffness matrix 2. You add and then that is you got as a 8.6. Now G. The third answer is what? You can third 3, 2. Then what is the next one answer? Is a 1, 3 is again answer is 0. The 2, 3 is minus 3 and 3, 3 is plus 3. Okay. Now all the data you substitute, that is called as your assembled stiffness matrix. This is the very important step. So if you correct or wrong, you can verify that. Where you gonna add the horizontal or add the vertical, you got the correct answer. Yes. If you got a 0, your answer is correct. You add all the summation of the row, all the summation of the column. If you got it as a 0, the answer is correct. Now you can proceed to the next step. What is the next step? You have to substitute the general matrix. So there is the general matrix F is equal to K into U. So the force matrix is nothing but if your data is given, talk about the force, you have to substitute. Otherwise, you leave as a 0. So, where is the force is applied? Either node 1, node 2 or node 3. Okay, that is very much important. So, if I consider node 1, node 3 is a fixed means, there is answer is 0. Only F2 is there. That is F2 is called as a P. That is the load is given. That load value is already told the Armugam is like a 200 kilonewton. That data you have to substitute. Then you can solve them and substituting the displacement also. That is U1, U3 is 0. Why? Because when I am applying the boundary condition, okay, what happens? The both sides are fixed. So that only the displacement is 0. So I cancel the corresponding rows and column. I got eliminate them. I got the final answer for this case is I got U is equal to 0.2325 mm square. So this is the outcome of this problem. Thank you.